good morning. It's Ishala Identity Michael once again, and I welcome you all to Success Enlightenment. Alright, today on Success Enlightenment, we'll be going through some basic econometrics proofing. Alright, there are certain identity in econometrics that is very important to be understood by students of what of econometrics. Our understanding of this basic identity is very essential to the econometrics algebra. And I've taken my time here. I'll be proving this basic econometrics identity. We are going to start establishing the basic econometric identity from the already established known statistical identity as the discipline or the branches of economics. Actually, I will use the word discipline. Discipline of econometrics actually what is drawn on statistics, not just statistics, it's drawn on mathematics, statistical inferences, and econometric theories. All right, with less words, let's go straight right into the point. Don't forget to like and subscribe to this channel. Comment on the comment section if you find any of the basic econometric identities that I'll be proving here. If I find it difficult for you to understand, just come right to my DM. You can call me straightforward. My phone number is attached to this. I remain Ishala IDJ Michael, and I welcome you once again to Success Enlightenment. All right, the first thing we have to remember is the already established statistical identities. All right, what are the established statistical identities? In your statistical analysis, in your chi-square analysis, in your correlation analysis, you already know that we have the distinction between small letter x, small letter y, and capital letter x and capital letter y. Alright, the capital letter x, the capital letter y, they are the given word variables. That is the data about the or given word variable dependent and independent variable. Why the small letter x and small letter y, they are the deviation. Right, they are the deviation of the observed data about this variable from its mean. And that's why you have a small letter x equals to capital letter x minus the mean of capital letter x. Alright? You have also your small letter y to be capital letter y minus the mean of capital letter y. Alright? These are deviation, right? It's a deviation from the absolute value of the observed variable, right? And you know this even right from secondary school. Right from secondary school, like this S bar means the mean of variable x, the mean of the observed data of variable x, which is the summation x divided by n. Alright, summation x divided by n. Some of you we said S bar is summation fs over summation x. This is for grouped data. This is for group data when data is much. You have the frequency. All right, but this is the basic identity for mean. This is the basic identity for mean. The same thing. All it changes that here we are concerned with the variable x, and here we are concerned with the what variable y. All right. Then here we have our what the first introduction of what basic what econometrics identity, which is the k is equal to this small letter x. Small letter s divided by summation s square, right? Small letter x divided by summation s square. In all your solvings, you must always know that there is always a difference between small letter x and capital letter x, small letter y and capital letter y. And in your proving, in your solvings, you must always be conscious of this. When you need to write small letter x, don't make a mistake of writing capital letter x. When you need to write small letter y, don't make the mistake of writing capital letter y. And with this, just 1, 2, 3, 4, 5 identities, now we can prove up to 10 basic econometrics identity from just this. So let's get right into it. Briefly in these videos, the following 8 econometrics identity will be proved. Alright. We are going to prove that summation of small letter x is equals to 0 and summation of small letter y is equal to 0, as well as summation of what k is equal to 0. Right? Also, we are going to prove that summation of k square is equal to 1 over summation of what small letter s square. we are going to prove that summation of k small letter s equals to 1, as well as summation of k small letter y equals to summation of k capital letter y. Also, we are going to prove that summation of small letter xy equals to summation of small letter s capital letter y, also equals to summation of capital letter x small letter y, and finally also equals to summation of what? nxy minus summation of x summation of y capital letter. Now, and finally we are going to prove that what? Summation of small letter s square equals to summation of n summation capital letter s square minus summation of capital letter s all square. All right. These are the first basic identity we'll be proving in this video. We are making 2 videos to cover this basic econometric proving, but this is the first part. I'll make the later part, but it's always advisable you have a mastery of this. Then from this you go into the other a little bit advanced econometrics proving. Okay, with that being said, let's get right to proving the first basic econometrics identity. Mathematically, when you have problem, like you're having a question that involves what? Proving. Right, you can either start proving from the right hand side or from the left hand side. But from here, since 0 is what you are having on your what? On your right hand side. So it's better you start proving from your what? Left hand side. Alright, the first steps you do in every proving is what? You state that is the intention. You make it clear. That's the first thing you do in any problem, in an examination situation that involve what? Proving. So the first thing you state is what? That is what you're actually doing. So you're right to prove. Yes, to prove the semicolon there. The next thing you want to make them realize that what do you need to prove this? So you have to recall, that is, your proving will have to be based on something that has been what? Acceptable. Right? It's like you have a fact, so from that fact you want to make another fact. You want to make a generalization, you want to make an inference. Alright? So you have to recall. And what we'll be recalling here is what? We need to know what is our small letter x. Alright, you have to record that our small letter x, record that x equals to what? Capital letter S minus what? S bar, which is the mean of x. Okay? So if this is this, then therefore we can substitute this for this. So if substitute this for this, then we have what? Summation small letter x equals what? Summation into what? Capital letter S minus what? S bar. Alright, now we leave the what? Right hand side. We have to solve this and make sure that the final answer is what? Is 0. Is it really true? Is the final answer really 0? Alright, so from here we can what? Open this bracket. We can expand this bracket. When you expand this bracket, you have summation s equals to what? Summation capital letter S minus summation times this summation s. Summation times s times mean of s will give you what? N s bar. And somebody want to ask me, why is it that summation times s bar is not equals what? Summation s bar. No, this is because s bar is a number. Alright, s bar is a number. If you have to find the summation of 1, 2, 3, 4, 5, this varies. This is a variable. This is not a constant. Alright, this is not a constant. So summation of this will be what? If this is what? S1, S2, S3, S4 to Sn. Summation of this will be what? Summation of S will then be what? S1 plus S2 plus S3 to what? Sn. That's why summation of S is what? Is like this. But now when you have to find the summation of what? 9, 9, 9, 9, 9, 9. So the summation of 9, 9, 9 is empty as what? N times 9. Alright? Just find the number of 9 you have. 1, 2, 3, 4, 5, 6. Here it will be what? 6 times 9. So this is why summation times S bar is N S bar. Do you get it? Do you get it? It's very, very simple. Alright? So because it is the same thing as what? How many 9 do you have? How many times? Alright, multiply it by what? One single value. Because it is a constant. S bar is a constant. It is a mean. Alright, the value you get for a mean is a constant. The mean of the distribution might be 12, and that will be all, might be 4, and that will be all. You can't have 2 means for a single distribution. It's not like mode that you can have bimodal, you can have more than one mode. But mean will always be 1. It is the average value. Do you get that? All right. With this being understood, then we can solve further from here. All right. From here, from here. All right. We see that we have our S bar. All right. So the next thing we can do here is what we find. We substitute this value of S bar because already see our S bar is already an identity in our statistical knowledge. So we recall again. Recall that S bar equals what? Summation x over n. So what we simply do is that we substitute this here. So therefore, our summation s equals what? Summation x minus n into what? Summation x over n. So from here, it is obvious that this n, we take this n out. So when this n take this n out, what is left? So our summation s now equals what? Summation capital letter s minus summation capital letter x. So summation capital letter s minus capital letter x, this will be what? Equals to what? 0. So therefore, summation s equals to 0. Proved. So by this we prove the what? Our first basic what? Econometrics identity. See how simple it is? Very, very simple. Right? Most times when students, when they hear the word proving, like, oh, but it's just very, very simple, very straightforward. All you just have to do is what? The basic identities. Don't forget them. Alright, don't forget them. And once you have them, all you do is what? Basic knowledge, principle of mathematics and statistical multiplication. Don't forget, this is very, very important. Summation times s bar, which is the mean of x, is we give you what? N s bar, not summation s bar, because s bar is a what? Is a constant, is a number. Alright, let's solve another our basic econometrics identity. Let's prove another one. Okay, yeah. Alright, yeah, alright. The identity we're proving here is summation of small letter y. Right, it's still the same procedures. Just don't forget it. The first thing you have to indicate is that your task is to what? Is to prove. So you write to prove. Alright? To prove. So for us to prove, we need some basic recall. We need some basic identity that we have established before. So recall that what is your small letter y is what? Capital letter y minus y bar. So you substitute this here. So therefore your summation y will then be equals to what? Summation into what? Y minus y bar. So what you do next is what? You expand this bracket. You expand this bracket, and when you do, you have your what? Summation y to be equals to what? Summation y minus what? N y bar. I already explained why this will be what? N y bar and not summation y bar. So what you do next is what? You recall again. You have to find the value of your what? Y bar. Recall that your y bar equals what? Summation y over n. So by this, then your summation small letter y will now be summation y minus n into what? Summation y over n. This n, we take this n out. Your summation y will now be what? Summation capital letter y minus what? Summation y. Capital letter y minus capital letter y, that is this summation of capital letter y minus summation of capital letter y will give you what? 0. So therefore, small letter y equals to 0. Proved. Alright, so it is as simple as that. So now, just in less than how many minutes, you've already proven what? 2 basic econometrics identity. It doesn't get easier than that. It is as simple as A, B, C. Alright, let's continue. Let's do further proving. Alright, the third identity we'll be proving today is summation k is equals to 0. Alright, still the same procedure. You state your motive first, which is what? To prove this. So we recall that what is our k? K equals to s over summation s squared, all in what? Small letter. So therefore, if k is this, then summation k equals what? Summation into what? X minus s over summation s squared. Alright, you expand this bracket, you open this bracket. When you open this bracket, what we have about summation k equals what? Summation x over summation s squared. Now recall, you already know what your summation s is. Anytime you see summation x is equals to what? Is 0. I mean summation small letter x. So therefore, we will recall from here. Recall that summation s is equal to 0. We've already proven this. So therefore, summation k equals what? Is 0 over summation s square. Now anything in mathematics is 0 divided by anything is equal to what? 0. Meanwhile, anything divided by 0 will be what? Undefined. So in this situation, we have 0 divided by summation s square, which is equals to what? 0. So therefore, summation k equals to what? 0. This is proved. Alright, it's as simple as this. Just in less than how many minutes, we've already proven 3 basic econometrics what? Identities. It is very, very simple. Very, very simple. All you just have to do is what? Just just watch and watch again. Watch the video again. Right, so I don't forget. Then take it out. Take your time out. Write all these identity out in a book and take another book. Keep solving it, proving it on your own. At your leisure time, proving it on your own. Before you know it, you have a mastery of all of them. All right, let's continue so that we don't waste more of our time. Let's continue. The next econometrics proving, which is the fourth one we'll be proving here, is what is summation k squared. I think summation k squared is equals to 1 over summation small letter s squared. We have to prove. So we state our motive first. So to prove, we have to recall that k equals to what? S over summation s squared. So if k is equal to s over summation s squared, don't forget the small letter x. Alright. So then what will be summation k squared? So summation k, no, let's not do summation k squared for, let's do what will be k squared. Alright. K squared will then be equals to what? X over what? Summation s square all square. Alright, s over summation s square all square, and this will be then our summation k square equals what? Summation into what? X over summation s square all square. This summation. Alright, now don't forget this can be further rewritten as well. This will be what? S square all over summation s square summation s square. Alright, so therefore we have this is what? Summation into what? S square. Don't make the mistake of writing capital letter X. Always small letter x where you have small letter x. This is a very easy mistake. You see me, I just made a mistake myself. This is a very, very easy, simple mistake. And once you make that mistake, you might be right, fine. But for the fact that you write capital letter S, you've already lost your mark, right? And you don't want to have that experience as a student. You read after spending night, day, data, studying, and just one mistake deprive you of the most suited grade that you could have gotten in a particular course. Please and please be very, very careful of that mistake. It's very easy. Even experts make it. Please and please. Alright. So from here, all you do here, you have what? You've already getting here. So put the summation. Alright, put the summation. You have what? This will be taking the summation. I multiply it by the summation here. You have what? Summation s square all over summation s square summation s square. So therefore, our summation k square equals to what? Summation s square all over summation s square summation s square. So definitely s square they will take each other out. So therefore this is same thing as what? 1 over summation s square. As this we cancel this. Okay, so therefore summation k square equals to 1 over summation s square, which we have to prove. So this is what proved. You see, it's very, very simple. Very, very simple. All we do here is what? We know our k identity before, so we put it there, we just expand it, we open this up. I try not to open it up at once, right? So that's why I come here first before I tell you what this is. Right? This we take square, this we take square. Right? It's just the same thing as when you have something like this. You have 2 over 4 all square. This all square. This is as what? 2 square 4 square. Alright? This is 2 square 4 square. And this will be 4 over 16. 4 over 16, which I guess will end up be 1 over 4. Am I right? Yes. And if you have done this will be what? This will be 1 over 2. Let's do division all square, which is still end up what? 1 square over what? 4. Which is over that, which is 1 over 4. Alright. So So just that, don't forget this square goes for the two of them. So once you do this expansion, it's very simple. This cancel this, you're 1 over s squared. Very, very simple and straightforward, right? We just done with the word 4 basic econometrics proving. In this video, as I said earlier, I'll be covering just 8 basic econometrics video. I'll do another video that I will cover some other proving in econometrics. The goal is not for us to rush. The motive is for us to what? Get it and get it once and for all. This thing is simple as ABC. If I can know it, trust me, you all can know it. You are more intelligent than I can ever be. I'm not flattering you, it's a fact. Alright? All you have to do is just get this and get this once. Alright? Thank you. Let's continue. Alright, the next one we're proving here is what? Summation k small letter x is equals to 1. Alright, we've already know the procedure. So what are we going to do? Simple, we state our motive first. Alright, to prove, we have to recall that k again equals what? S over summation s squared. Alright, so if k is this, then summation, before you go to summation, what will be your what? Ks. Just do the product. Alright, so your ks you what? X, don't make the mistake of putting capital letter x is small letter x that you have here, over summation s squared into what? X. So your kx then equals to what? S squared into what? Summation s squared. Alright, now you can bring the summation. Now if ks is this, then what will be summation ks? So therefore, then summation kx will now be equals what? Summation into what? S squared all over summation s squared. This already have summation, so you cannot have summation squared. Alright, summation times summation is still what? Summation. So therefore, this will be equals to what? Summation this small letter x. See, I keep making that mistake, moving myself. Alright, so that's how you know you have to be more vigilant when you are in the exam situations, please. So you have this is what? Summation s squared all over what? Summation s squared. Summation s squared by summation k equals to what? 1. So therefore, summation kx equals to what? 1. Proved. I don't think there is anything as simple, as easy as this. Very, very simple, direct, and straightforward. Okay? And the beauty of it is, for 300 level economy study, you see this in your test and you meet this in your examination. So I see no excuse for a failure. Seriously, all I see is what? Is A and B. Simple. It's as simple as that. So let's go forward. Let's see the 6th basic econometrics what? Principle. Basic econometrics proven that have been as proven here. Alright, let's go ahead. Let's see what we have next. Alright, let's go ahead with the 6th one. Right, we have summation k small letter y equals to summation k capital letter y. Right, how does this small letter y changes to capital letter y? Let's prove. Alright, to prove, first thing we need, the main thing we need here is what is our small letter y. We already know our small letter y should be what? Capital letter y minus what? Y bar. Alright, if this is this, then what is our k small letter y? So k small letter y be what? K into what? Y minus y bar. Don't forget this time we are dealing with capital letter. So if you expand this bracket, you have what? Your ky minus what? Y bar. Okay. Don't forget this y bar is a number, right? When you are multiplying a number, right? You always end up as what? As a coefficient. You can never have x2. What you have is what? Is 2x, because this number is a what? Is a coefficient. It's a number, right? So don't always, this is a small principle. You are supposed to be taught in what? Basic mathematics in your elementary and secondary school knowledge. Alright, but if you don't know it, just get it once and have it in your head. It will save you a lot of stress in further studies, especially in what? In econometrics, statistics, and economics analysis generally. Alright, let's continue. So from here we already know what is our what? Our ky. So what is summation? What is summation ky? Alright, what is summation ky? So from here, summation ky equals what? Summation into what? Ky minus what? Y bar k. Right? So expand this bracket. So summation k small letter y equals what? Summation k capital letter y minus what? Y bar summation k. And recall, we've already solved what is summation k. Recall, that's where our third proving. Summation k is already proven to equals to what? Is 0. If you remember. So therefore, from here, summation ky equals what? Summation k capital letter y minus 0. So therefore, summation ky equals what? Summation k capital letter y. Now we've proved it. You see how simple it is. Very, very simple. I love to tell people econometrics is simple because it's a discipline of what? Of procedures. When you master the procedures, you get the answer perfectly. It's just for you to just master the procedure and cultivate the habit of what? Solving and solving. Alright. We treating just 8 in this video, and we're already at number 6 in just how many minutes? So now let's see the 7 and 8, then we call it a day in this video. The next video, I will be treating a little bit more advanced, not complicated like that, not complicated basic econometrics proving. They are very, very simple, straightforward and direct, but you just have to know this. You have to know them. So right, let's go to the 7th proving. Alright, now we get to the 7th basic econometrics proving. We look at this look like this equals this. How come? Alright, it's 3 proving we'll be doing here. So let's do the first one, which is what? Summation xy equals to summation xy. Alright, let's do this first. So alright, to prove, recall, small letter x equals what? Capital letter S minus what? S bar. So therefore, small letter xy will now be what? Small letter y into capital letter S minus what? S bar. Alright, it's not what you have been doing before. So here you multiply, you have what? Small letter y x minus s bar small letter y. So put the summation. So therefore, summation sy equals what? Multiply summation here, you have summation x small letter y. It doesn't matter you arrange which one you put for, minus what? S bar summation y. Now recall, we've already find what's our what? Summation small letter y, which is equals to what? Is 0, right? So therefore, summation xy equals what? Summation capital letter S small letter y. Since everything here is equals to 0, proved. We've already proved that this is equals to this now. Okay? We've already proved that this is equals to this. Now let's do the second proving. See how simple it is? Then the second proving, which is what? Summation xy equals what? Summation small letter s capital letter y. Alright? Is this still equal? Alright, let's see if it is still equal. So from here, we state our motive, which is what? To prove. Alright? So to prove, we have to recall that our y, small letter y equals what? Capital letter y minus what? Y bar, capital letter y bar. So therefore, our sy will be what? Small letter s into what? Y minus what? Y bar. Okay? So from here, we open the bracket, we have what? Small letter x capital letter y minus what? Y bar small letter x. So you bring the summation in. So therefore, summation sy equals to what? Summation small letter s capital letter y minus y bar into what? Summation small letter x. So now you have to recall that summation small letter s equals to 0. So which is everything is equal to 0. So therefore, summation sy equals what? Summation small letter s capital letter y. Proved. We proved it to be equals to this as well. Alright? See, but in most cases, what they will ask you is prove this to be equals to this. Alright? That's what they will ask you. But you just have to understand that this is still equal, still basic proving. See how sweet is this? Very, very simple. Simple, straightforward, and sweet. Alright? So now let's prove this to be equals to this, and by that we'll be done with this, and we solve the last proving, then we move to our next video. Alright? Alright, we're going to the last proving there. Alright, the last proving there. And the last proving we have to prove that summation xy equals to n summation capital letter xy minus summation capital letter x summation capital letter y. Alright, we state our motive, which is to prove. Then we go into our recall. we call that small letter s equals to x minus s bar, and small letter y equals to y minus what, y bar. Alright, so now that we have this, we can find what is our small letter s y, which will be the product of this, that is s minus s bar capital letter, y minus y bar capital letter. Alright, if you are expanding this bracket, you can write it as this: s into what, y minus y bar minus y bar into what, y minus what, y bar, minus s bar into y minus y bar. Use this to multiply this. You can as well use this to multiply this, it will give you the same result. Alright, so from here, let's further open this bracket. So our x y will be bracket x y, this times this, minus this times this, which is what, y bar x. Don't forget, this is a number, so it should always appear as a coefficient. Alright, this time this will be what, minus what, s bar y. This time this one has already be plus, this will be plus what, s bar y bar. Alright, so from here, what we are giving is summation sy. So we find what is sy. So the next thing we check is what, we apply, we put the summation to it. So when we put the summation to it, what do we have? So summation xy, we then go what, summation into xy minus s minus y s bar minus s bar y plus s bar y bar. So multiply all this by summation. So you have this word summation capital letter sy minus y bar summation x. This is the number, don't forget this is the coefficient. This is variable rather. Minus what, s bar summation capital letter y. These are both what, number, they are both constant. So the summation will just bring n to it, and this is what, plus what, n s bar y bar. It's as simple as that, right? When you multiply this by summation, what you have is n s y s bar y bar. So here we cannot collect the like times because these have different variables. This s, this is y. So what we do here is we recall again what is our what, s bar is summation x over n, and what is our y bar, which is summation y over n. So now therefore this will then equals what, summation sy. Whenever we see s bar, whenever we substitute this for this, which will then be what, a minus what, summation y over n summation x minus what, summation x over n summation y plus n into what, summation x over n summation y over n. Alright, do we get that? Yes, we do. So from here, let's manage this space. From here, summation, don't forget this. Okay, sorry. This, I thought we have the small letter. So then we now be equals to what? Here we have what? Summation sy. This is the same thing. Either way we write it, they are what? They are commutative. Alright, multiplication is commutative. Y same thing as sy. So this will be minus what? Summation. Let's use sy. This is the same thing. So you have minus 2 summation sy over n. Alright, this is the same thing. Minus and minus. This is the same thing. This and this is the same thing. So you add them together to 1. So this will now be plus. What we have here is n. 1 n cancel n. So there's no point writing n here again. This n, we take this out. This n, we take this out. So what we have left is what? Is summation x summation y all over n. Alright, this we take 1 out of this, right? So once this take out of this, so what is left? What you have left is what? Is summation x y. Don't forget to write your equals to summation sy minus summation x summation y over n. That's what we have left. So this is now, if you can multiply everything here by n, if you multiply by n, this is same thing as what? This is same thing as what? N summation sy minus what? Summation s summation y. Proved. Alright? Proved. All you do is what? All you do is multiply everything by n. So this n times n, this will be 1. This will be n summation sy minus summation x summation y, which is this. So we'll be able to prove this identity to be all equal. Alright? We'll prove this identity to be all equal. This one as well is very, very simple. The only difference here is that what? it just take more space, right? The steps is still the same thing, just record and substitute, and you are here already. The only place that is technical a bit here, I've already explained this. Add this, multiply this by this, turn to this. So it's very, very simple. This plus this will give you 2 summation sy n. So this we cancel this will be 1 summation sy. So when you take this from this is what you have left there. Multiply both by multiply n through so that you want to take this division sign away. So what you have left is what? N summation sy minus summation x summation y is as simple as that. Let's do the last proving and we call this video as we bring this video to an end. Alright, this is the last proving, yes. And let's just do the last proving and I'll be done. The last one I did, I think that the power of the mic was a little bit low. Alright, I hope you're able to hear me. It's audible enough. If you can't, please just get back to me. Alright, I'll be more than happy to explain it again to you. Alright, so summation s squared equals to n summation s squared minus summation s all squared. That's what we is our last basic econometrics proving. So very, very simple. You already know what we are doing. So to prove which is what we are doing, we have to recall what was our x. Recall that s equals to x minus s bar, right? Now s equals to x minus s bar, capital letter. So what is then is our s square. Our s square will then be s minus s bar square. It's the same thing as what? S minus s bar, which is also the same thing as what? S into s minus s bar. We open this bracket. Minus s bar into x minus what? S bar. So when you expand this, what do you have? We have what? S square minus s bar x minus s bar x minus plus minus plus s bar square. Alright, this you can calculate the like times. So here you have what? Your s square minus 2 s bar x plus s bar square. This is what your s square is. So what you are really dealing with is summation s square. So not really s square. So what is summation s square? So summation s square will then be equal to what? Summation into what we have here, which is s square minus 2 s bar x plus s bar square. So when you multiply all through, use this summation to open this bracket. So when you do that, what you have will be what? It will be what? Summation s square minus 2 s bar summation x, okay, plus n s bar square. Don't forget summation times that mean you have n, not summation s bar. I've already explained that multiple times. So I believe we are good here. Okay. So from here we have to recall what is our mean? S bar, which is what? Summation s over n. So let's substitute this here. So what do we have? What we have will now be what? Summation s square minus 2 summation x over n summation x. You multiply this, everything will turn to this, okay? Plus n into what? Summation s over n summation s over n. This we cancel this. So what we have left is what? Is summation s square minus 2 summation x, okay, over n plus this is summation x all over n. Alright, it gets a little bit confused for some people there because I had to draw the line. So let me just clean it up here and continue there. Let me just clean this outside because what we did here is the same as what we did in the last proving that we just solved. So now from here, what do we do? From here, this and this we take one out of this. So what we have left is what? Is summation s square minus summation x all over n. And if you multiply this, if you multiply through by n, so what we have here will be what? N into what? summation x square minus n into what? Summation x all over n. We do this so that we can eliminate division out of our answer. So what we then have left will be n summation s square minus summation x summation x. Summation x same thing as what? Summation s all square. So therefore summation s square equals to n summation s capital S square minus summation s all square. Proved. It is as simple as that, and this is 8 solid basic econometrics proven. All right, you have to learn how to prove this. You have to master it. It's going to come out in the evaluation situation, and also you have to have it in the back of your mind that when you have this, when you have summation s, what what is equal to is what is zero. In the knowledge in basic econometrics, what algebra, when you have summation y, this one is that y is equal to 0. When you have summation k is equal to 0. When you have summation k square, what you are dealing with here is what? The 1 over what? Summation k square, what you are dealing with there be what? It be 1 over summation s square. When you have summation kx, what you are doing is what is 1. Alright, you have to have all this in your head, and the only way you do it is not by cramming, is by you yourself on your own personal space attempting to solve this, proving one after the other. Watch my videos, try to solve them. If you get confused with anyone, call me, DM me personally. I'll be more than happy to be of help. Alright, thank you with this. We bring this video to an end. Don't just watch, don't just like, don't just comment, subscribe, so that next time I do a quality content like this, you'll be the first to get notified for this. And thank you once again. My name is Inshallah Adedeji Michael, and this is Success Enlightenment. Stay blessed.